Hey guys, today we're going to be doing the 2014 AP Calculus AB free response question number 4, which relates to Riemann sums. So let's just get into it. So, number 4 reads, Train A runs back and forth on an east to west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function VA of t, where time is measured in minutes. Selected values for VA of t are given in the table above. And so as you can see, time is increasing from 0 to 12 on the table, and how the VA of t increases and then it steadily decreases. Okay, so we'll read part A. Find the average acceleration of train A over the interval 2 is less than or equal to t is less than or equal to 8. So for this one, for A, we're looking for the average acceleration. And so to do this, you have to set up an integral. So it would be, the question says 2 to 8. So it would be 2 to 8. And then it's the acceleration, the average acceleration. So it would be a of t here. In respect to time. And so if you know that the integral of acceleration is velocity, you can just look at the table and how it relates to velocity from 2 to 8. So v of 8, because a of 8, its integral would be v of 8, minus, this is just the slope formula, over 8 minus 2. And if you look at the table, it's going to be negative 120 minus 100. Negative 120 minus 100 over 8 minus 2. So that'd be negative 220 over 6, which can be simplified to negative 110 over 3. And then the units for this would be meters per minute squared, because it would be the velocity, which was measured in meters per minute, over minutes. So the units would be meters per minute squared. And that's part A. Part B reads, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with 5 less than t less than 8? Give a reason for your answer. Okay, so it's asking us if at any point is there a value of time where VA of t is equal to negative 100. And you can see that on the table, it goes from, it's looking at the times 5 to 8. So you can see that it goes from positive 40 to negative 120. And since VA of t is continuous, and VA of 8 is less than negative 100 is less than VA of 5. Therefore, using the intermediate value theorem, we know that VA of t equals -100 for some t value between 5 and 8. Next question. At time equals 2, train A's position is 300 meters east of the origin station and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time equals 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time equals 12. Okay, so let's first figure out this integral. We'll say let a of t be the position of train A at some time. Okay, and we're looking for the position of train A in meters at time 12. So we're looking for the position. We said A of t for at 12 seconds. And so this is going to equal the initial condition, A of 2, which was 300 meters, plus the integral from 2 to 12, because the final is going to be 12 and we started at 2, with v a of t. Because if you take the integral of velocity, it's going to be position, right? And that's what we're looking for in respect to time. Okay, so now we just plug and chug. So we said A of 12 is what we're looking for, equals A of 2, our initial condition, which was 300. And it tells us to use a trapezoidal sum, so that's going to be base times height divided by 2. So it'll be the two bases added together times the height that's given. So you can see here this VA of t is what we'll be using to add as the bases, and then we'll multiply it by the difference in the time. So 3 would be the case here, and 140 would be the case here, and divide that by 2. And same thing for the other 3, so 2 to 5, 5 to 8, 8 to 12. So we'll write that down. So it'll be plus 3 times 100 plus 40 divided by 2 plus 3 times 40 minus 120 over 2 plus 3 times negative 120 minus 150 over 2. And so if you solve for those, it's going to be A of 12 equaling 300 plus 210 minus 120 minus 540. So that means that a of 12 will approximately be equal to negative 150. And that's your answer for part C. Part D reads, a second train, train B, travels north from the origin station. At time t, the velocity of train B is given by Vb of t equals negative Vt squared plus 60t plus 25, and at time 2, the train is 400 meters north of the station. And find the rate in meters per minute at which the distance between A and B is changing at time equals 2. For the previous problem, they said that train A was going east. For this problem, they're saying that train B is going north. And so what we have here is a triangle, and we're trying to find C, the hypotenuse. And to do that, we have to use Pythagorean Theorem. And the cool part was that they said that, hey, at 2 seconds, A went 300 meters. And at t equals 2 for B, it went 400 meters. So that means just using basic geometry and knowing what a 3, 4, 5 triangle is, we know that C is going, at C, it went 500 meters. Right here, this is 500 meters. Okay, so we'll write out Pythagorean Theorem. We know that it's a squared plus b squared equals c squared. And so we'll differentiate this so that the 2's come down, and we can use the the velocities for each variable. So it'll be 2a times the velocity a plus 2b times the velocity at b, and equaling 2c, and we don't know what the velocity is going to be, but it's going to be the differentiation of dc over dt, right? And they gave us VB. VB equals negative 5t squared plus 60t plus 25. And so we just have to substitute for the time and solve for the velocity. So that would be VB equals negative 5 2 squared plus 60 times 2 plus 25. And so what that equals is VB equaling 125. Right? And so now we plug this back into the original equation that we had, the 2a times VA plus 2b times VB . equaling 2c dc over dt. Right, and now we just substitute. So that would be 2 times the position at A, which was 300, times VA at time equals 2, which was 100, plus 2 times 500, or 400, sorry, 400, times the VB that we just found, which was 125, equaling 2 times 500, because we said that it's a 3, 4, 5 triangle, times dc over dt. And so if you work this out, you get that dc over dt equals 160 meters per minute. And there you go. That's part D. Okay, I hope you guys enjoyed. If you have any questions, leave them down below. And thank you for watching.